This is our last lesson. We're going to put together everything we've learned and factor completely. So let's take a look at the warm-up, and we're going to look at these two terms here and find what's a common factor in both of them. Look for that GCF, or greatest common factor. For B, this one you have to do the factor just traditionally and look at what multiplies to negative 13 and adds to negative 12. And for C, you're going to factor this by grouping. Make sure you change that middle negative to a plus and negative before you factor. I'm not going to solve these. These are all warm-ups from 7.9 and 7.10. Today we're going to talk about factoring completely, though. So let's look at this first example. The first thing we want to find is a common factor. In this case, yep, there's a 3. So we have this 3 factored out in front. How many terms are left inside the parentheses? 2. And so now we think about what are the patterns that we know with 2? Well, a difference of 2 squares. 4 is a perfect square, and a squared is a perfect square. So that factors nicely into this section right here. And remember, we have to keep our 3 from before. Finally, is there anything else to factor? Nope. So a couple of golden rules: always look for a common factor, be careful of leading negatives, and always ask if there's anything else. So let's take a look at number 1. Common factor is going to be a 2. That gives me x squared minus 9. Is there anything else? Yes, it's another difference of perfect squares. So that's going to be 2 times x plus 3 times x minus 3. And it might be helpful to just kind of have your patterns next to you so that you can recognize them. For number 2, a common factor in all of these is going to be a 4. So x squared, 40 divided by 4 is 10. 100 divided by 4 is 25. If you don't recognize that pattern right away, it's okay. We can also think about what multiplies to 25 and adds to negative 10. And if you think about all your factors of 25, 1 and 25, or 5 and 5, it's going to be a negative 5 and a negative 5. So that's going to turn into x minus 5 and another x minus 5. And don't forget our 4 from up here. So this is completely factored. For number 3, there's no number that's a common factor, but there is a common variable, which is an r. So that leaves us with r squared plus 2r plus 1. That 1 is very important. Don't forget it. If I were to distribute at the end, I'd want to end up with an r, not with a 0. So that's why you have to put a 1 there. This is also a perfect square, but you can think about what multiplies to 1 and adds to 2. So r times r plus 1. And this time I'm going to write it as a perfect square. Either one is correct, whether you write out the terms like in number 2, or if you put the exponent. They're both correct. Number 4, common factor is going to be a 2x. That leaves us with x squared minus 7x minus 18. What multiplies to negative 18 and adds to negative 7? So we've got 1 and 18, 2 and 9, or 3 and 6. And 2 and 9 is going to give us that negative 7. So those numbers are going to go here. And we want the 9 to be negative, so I end up with a negative 7. That gives me the factors x plus 2 and x minus 9. Don't forget that leading 2x from above. So what if we have a leading coefficient that's not equal to 1? Here's where it gets a little bit more complicated, and this is not going to be tested in Algebra 1. So first of all, we want to look at the first term and the last term, what multiplies to their product, or multiplying them together, negative 4v squared, and adds to the middle term. So the difference here is that we multiplied before we put that number up there. So listing them all out, either 1 and 4 or 2 and 2, we're going to go ahead and use 1 and 4. We want the 4 to be negative so that our 3 is a negative. That gives us the factors x plus 1 and x minus 4. But wait, that doesn't seem to make sense. So we can't do that. Instead, we're going to have to use our area model. And in the area model, we put the leading term, 2v squared, up in the upper left, and the ending term, negative 2, in the bottom right. We take the middle terms that we came up with, this 1 and negative 4, and we can put them in any order, as long as they fill in the box. And now we're going to factor out. So if we factor out, looking at what multiplies into both 2 and 4, we're going to get a 2v here. 2v times what is 2v squared? Well, 2v times v. 2v times what is negative 4v? Negative 2. So I have 2v here, v, negative 2. What's going to go in the missing blank? Well, common factor is just going to be 1, because 1 times v is 1v, and 1 times negative 2 is negative 2. So that's what gives us the factors. My first factor is 2v plus 1. And my second factor, reading down, is going to be v minus 2. And that's completely factored. It's pretty tricky, so let's take a look at one more. Multiplying what multiplies to 9n squared negative and adds to a negative 8n. Well, it's kind of a similar pattern. In this case, it's still going to be 1 and 9, and the 9 is negative here. Go ahead and put n's right there. And since the leading term isn't 1, I can't just jump ahead and use my factors. I've got to use that area model. So the first term goes in the upper left. That's 3n squared. Bottom term is negative 3. Use the numbers that we came up with, this 1 and negative 9. It doesn't matter where we put it. Okay, let's factor out this first column right here. What's something that goes into both of those? Well, it's going to be a 3n. And what's something that goes into the second column? Just a 1. 3n times n is going to give me n squared. 3n times negative 3 is going to give me negative 9n. And sure enough, negative 3 times 1 is a negative 3. So my factors are 3n plus 1 and n minus 3. Let's go ahead and do one last one, which is number 8. Common factor is going to be a 4. Always start with your common factor. It'll save you a lot of time. That leaves us with 2x squared minus 1x minus 6. Unfortunately, my leading term still isn't 1. So what multiplies this times this is negative 12x squared. And my middle term is negative x. Let's list out the factors. And I think I'm going to use 3 and 4 with a negative 4. Okay, so now we're going to put this into our table. And we have to use the leading term from the factored one. We don't want to use our 8x squared. We want to use the 2x squared. And the ending term goes down here. The terms that we found in any order. And then we factor out. So something that goes into both of those is going to be 2x. Something that goes into both of those is going to be a 3. 2x times x and 2x times negative 2. Don't forget the 4. So 4 from the beginning, 2x plus 3, and x minus 2.